This week's problem of the 1000 GeV kinetic energy proton in a collider that collides onto a proton that is standing still in the frame of reference of the collider. That problem turns out to be not so successful. I've had about 50 answers and only 2 were correct. And yet this problem has been on the air now for 5 days. So I'm not sure whether I will post my solutions this Saturday. I may want to wait longer to give you more time. I will show you 4 separate solutions. In the first video, I cover most of the theory and I give you 1 solution. Then I have to go to another video because I'm limited by the time that I can videotape. It's limited by the battery in my cheap camera. So then I make a second video, and in that one I give you 3 solutions. 3 independent solutions, 3 additional solutions. All 4 solutions give the same answer to an accuracy of 5 digits. Clearly the problem is that special relativity is below most people's horizon. It is very different from Newtonian mechanics. Yes, of course, momentum is conserved in every collision. That's about the only connection with Newtonian mechanics. In Newtonian mechanics, when you have an inelastic collision, kinetic energy is destroyed, and in general, it is converted into heat, because total energy, of course, has to be conserved. So if you fire a bullet into a block of wood, that bullet comes to a halt, so all kinetic energy of the bullet is destroyed, and most of it probably is converted to heat. Maybe some of it to sound, and some of it to actually drill a hole into the wood. So, in colliders, of course, total energy is also conserved. And with any collision, momentum is conserved. But in the case of the colliders, of the accelerators, a large fraction of the kinetic energy of the protons, in this case the 1000 GeV proton, can be used to create new mass. That's where Einstein's theory of special relativity comes in. And in our case, all I'm asking you is, what is the largest rest mass in this particular collision, which could have been done and was done with the Fermi accelerator? What is the largest mass, capital M, that in this collision can be produced? Of course, it could also produce maybe 2 particles. But that's not the problem here, because the total mass of 1 particle that could be produced, so all I'm asking you, what is the maximum value of that? In the case of the Large Hadron Collider, it was built, the main reason, multi-billion-dollar accelerator, the main reason was to find the Higgs boson. If the rest mass of the Higgs boson would have been larger than the maximum mass that LHC could create, then they would not have found it. But luckily that was not the case. So the Higgs boson, which has a mass of 125 GeV, that is of course the mc squared of the Higgs boson, was lower than the maximum mass that LHC could have produced. And so they were lucky, they found it, and they got the Nobel Prize for that. So I don't know quite when I will post the solutions. I want to give you more time. As we speak, I am watching on my computer the total lunar eclipse. It just in Los Angeles, the lunar eclipse in Los Angeles just entered totality. Wow, it's very interesting to see. I see the actual live pictures of the Griffith Observatory in Los Angeles. Okay, so it is about it's about 8 o'clock here, almost 8 a.m. in the morning, and it is January 31. So, good luck with the 1000 GeV problem. And what I have learned from this is clearly that most of you really have no clue about SR. I don't mean to insult you, but the answers that I have received, some of them are off by 15 orders of magnitude. All right, maybe when I send you my 4 solutions, you may learn some physics, but I even doubt that. Maybe you don't want to be friends with me anymore because of this problem. Nevertheless, have a nice day and take care. And let's still try to be friends.